Hi, my name is George Dong, and this is my presentation of the Charge Tapes Lab for Physics 2212. Here's a little brief introduction. The purpose of this lab was to estimate the charge on a piece of clear tape and observe its interactions with other various objects. Some fundamental principles that we used in this lab was Coulomb's law, which is the 1 over 4 pi epsilon naught times QQ over R squared, and Newton's second and third laws. Some brief takeaways from my results. I found that the tapes were positively charged, and the charge on the tape was 1.2 times 10 to the negative 8 coulombs, and the magnitude of excess charge was 7.5 times 10 to the 10. For the purposes of this lab, it was assumed that each tape had the same net charge, and each tape was treated at a single point charge, which would be located at the center of the tape. And of course, the classic air resistance is negligible, which was the factor taken into account when observing and interpreting the motion of the tape. During my experiment, I observed that my hand attracted tape 1, while tape 1 repelled tape 2. From that, we can conclude that tape 1 and tape 2 share the same sign for the charge. A book I tried on tape 1 attracted tape 1, and a pen that I rubbed with a cloth to induce a negative charge on also attracted tape 1. So from the pen trial, we can conclude that tape 1 is a positive charge because the pen was negatively charged. And since tape 1 and tape 2 repelled each other, they must be also of the same sign. So both tape 1 and tape 2 are positively charged. Now let's move on to measurements and calculations. The first 3 shaded in bullets are the measurements I took during this lab. And with that, I calculated the gravitational force on tape B by multiplying the mass of tape B by the gravitational constant. And to get the charge on tape B, I manipulated the force due to electric field equation to isolate Q and substitute the correct values. To find the number of electrons in tape B, I took the charge of tape B divided by the charge of a single electron, and I got 7.5 times 10 to the 10 electrons in excess. And to calculate the number of atoms, I had to take the tape area divided by the atom area. And to find the atom area, we assume that the atom is shaped like a sphere, and the surface area formula for a sphere is 4 pi r squared. And given that the atom's length is 10 to the negative 10 meters, then we can say that the radius in this case would be 5 times 10 to the negative 11 meters, which ended up giving us the atom's area to be pi times 10 to the negative 20 meters squared. And the tape area, given that it's just a rectangle, is simply length times width, with the length being 0.2032 meters and the width being 0.0203 meters, and that gave us 4.13 times 10 to the negative 3 meters squared. And so dividing those two values yielded 1.31 times 10 to the 17 atoms on the tape. Now that we have the number of excess electrons and the number of atoms, we could find the ratio of electrons to atoms, which turned out to be 5.71 times 10 to the negative 7 electrons per atom. Here's my GlowScript model which the blue sphere represents tape B, and the red sphere represents tape A, both as single point charges. And the cyan vector arrow represents the gravitational force vector, and the green vector arrow represents the force due to the electric field. And the values for the charge on the tape and the number of electrons on the tape matched what I calculated, although this version is more precise. Now let's talk about some post-lab questions. Well, if the electrons had positive charge and protons had negative charge, from the observation standpoint, nothing would change, simply because attraction is determined by the signs of the charge being opposite, and repulsion is the signs being the same. And if electrons and protons swap signs, that property still holds true. Why is it important to handle the charged tapes as little as possible? Well, because the moment something touches the tape, then the charges begin to flow from the tape to said object. So if I am the person handling the tape, and especially since I'm grounded as an individual with my foot on the floor, then charge begins to leave the tape and the tape will become more neutral.